Let us consider f of x equal to p of x over q of x. Okay, be a rational function and let a be any number. Then if q of a is not equal to 0, then limit x goes to a, f of x equal to f of a. And of b, if q of a is equal to 0 but p of a is not equal to 0, then limit x goes to a, f of x does not exist. So let me consider some example. So limit x goes to 0, f of x, and here we have f of x equal to 1 by x. So 1 by x. So you can see that it is a p of a. Okay, yeah, you can say p of 1. Okay, and it is going to be equal to, sorry, it is p of x and it is q of x. So here p of x equal to 1 and q of x equal to x. But p of 0 is going to be 1 and q of 0 is going to be what? 0. So in this case you can see that limit is not going to exist. Limit x goes to 0, if you put 1 by 0, which is going to be what? Infinity. Okay, so here when we have x positive, okay, we consider x is going to be positive, then in this case we have plus infinity, and we have limit x goes to 0 minus, then we have 1 by 0 which is equal to minus infinity. So here let me write down x, only x. Okay, I'll tell you why I'm going to why I'm writing like this. I'll tell you. So now if you consider another example, limit x goes to 1, x minus 1 over root x minus 1. In this case we have p of x and q of x. Here it is going to be 0, means when we have q of 0 is going to be 0, q of 1. Q of 1 equal to 0, and here also p of 1 equal to 0. And we have find out, so limit x goes to 1. If you do, there are two methods to do. Either we can rationalize it, and yeah, we can use this formula, a square minus b equal to a square minus b square equal to a minus b into a plus b, right? And then we can further simplify it and use this formula to simplify. Okay, and we know that x minus 1 over root x minus 1 is going to be 2. Okay, so when we have two function, whenever we have p of x and q of x function, then the limit f of x, x goes to a, is going to exist if q of a equal to 0, okay, and p of a equal to also 0. We have seen this example, right? Now